What's up, everybody? This is your boy Tech G back with another video, and today we're going to be talking about storage types. So in this video, you will learn about the difference between various storage types such as volatile versus non-volatile storage, local storage types, local network storage types, and cloud storage surfaces. All right, so let's talk about volatile versus non-volatile. So volatile storage is a type of computer memory that needs power to preserve stored data. If the computer is switched off, anything stored in the volatile memory is removed or deleted. There is only one type of volatile storage, that is called RAM, or random access memory. Non-volatile memory is a type of computer memory that has the capability to hold saved data even if the power is turned off. Unlike volatile memory, non-volatile memory does not require its memory data to be periodically refreshed. It is commonly used for secondary storage or long-term consistent storage. There are many types of non-volatile storage, including magnetic hard drives, also known as spinning disks, solid-state drives, optical storage, flash drives, network storage, and cloud storage. Let's talk about local storage types. So local storage is the first type of storage available when you turn a computer, tablet, or smartphone on. Local storage does not require an internet connection or a network connection. All right, so here are some local storage types. The first one we have is random access memory, also known as RAM, or it could be called main memory, primary memory, or system memory. But it is a hardware device that allows information to be stored and retrieved on a computer. When you turn on a computer, smartphone, or tablet, the operating system is loaded into the computer's RAM, followed by apps or other processes that are loaded at startup. When desktops and with desktops and mini laptops, memory modules of various sizes can be installed to increase the amount of volatile storage available for the operating system, apps, and the data created, changed, or loaded. Memory modules for desktop computers are commonly known as DIMMs, which stands for dual inline memory modules, and laptop memory modules are commonly known as SODIMMs, stands for small outline DIMMs, or dual inline memory modules. So here's a picture. The image on the bottom left is a DIMM, a dual inline memory module. That is what you would typically install inside of a desktop computer. And then the image on your right is a SODIMM. That is what you would typically install inside of a laptop computer. Now, before working with any memory modules, you need to turn off the computer and unplug it from the AC outlet. Electrostatic discharge, also known as ESD, is a sudden flow of electricity between two electrically charged objects that can harm computer components. Be sure to employ ESD protection in the form of an ESD strap and ESD mat. So basically, an ESD strap is like a little wristband that you will wear with a metal contact that touches your skin. And then you connect that to like the outside chassis of a computer. So in case your body generates any type of static electricity, it'll pass through the chassis and it won't go directly onto the motherboard and cause damage to the motherboard. Let's talk about hard drives. So a hard drive, also referred to as abbreviated as HD or HDD, is a non-volatile data storage device. It is usually installed internally in a computer, attached directly to the disk controller of the computer's motherboard. It contains one or more platters housed inside of an air-sealed casing. Data is written to the platters using a magnetic head, which moves rapidly over them as they spin. Hard drives are available in two types. You have the solid state, and then you have the spinning disk, which uses magnetic storage. Let's talk about the solid state drive, also known as an SSD. An SSD is a type of mass storage device similar to a hard disk drive. It supports reading and writing data and maintains stored data in a permanent state even without power. SSDs are rapidly becoming the system drive of choice for laptops and convertible computers, as well as for performance-oriented desktop computers and servers. These drives use various types of high-performance flash memory to store files, and they can be used for the operating system, apps, and data. Because there is no need to move read-write heads to various storage areas of the drive to locate data, SSDs are faster than mechanical hard drives and are not affected by shock. SSDs can also be used as replacements for existing spinning disk hard drives in laptops or desktop computers, and they are also available in external versions using USB 3.1 Generation 1, which is also known as USB 3.0, and USB 3.1 Generation 2 interfaces. Windows 8.0 and later have built-in support for SSDs, but older versions of Windows require special configuration settings for use with SSDs. Mac operating systems 10.10.4 and later have built-in support for SSDs, and Linux distros or distributions based on the Linux kernel version 3.8 and later have built-in support for SSDs. However, it is recommended that you check the compatibility for a particular SSD and its controller with the vendor of your preferred Linux distro. So as you can see in the image, that is what a typical SSD hard drive looks like. Spinning disk hard drive. A spinning disk is the mechanism with a hard disk drive to which memory is written. With rotating plates attached to an arm that writes the data, the spinning disk mechanism physically resembles a record player, although it is sealed within an enclosure. The plates are magnetized, similar to cassette tapes, in order to store data that is written using copper heads. Although SSDs have become very popular as startup system drives, they still do not offer the cost per gigabyte or capacity of spinning disk drives. Spinning disk drives contain one or more aluminum or glass platters that have magnetic coatings. Read-write heads are moved to the correct location to read existing data and write new or changed data. A circuit board on the bottom of the drive assembly contains cache memory, the SATA controller chip, and the SATA power and data interfaces. Typical HDD capacity storage range from 500 gigabytes to 6 terabytes, but high capacity HDDs for desktops and small servers are now available in capacities as high as 12 terabytes. A solid state hybrid drive, also known as an SSHD, is a logical or physical storage device that combines a faster storage medium, such as solid state drive, with a higher capacity hard disk drive. The intent is adding some of the speed of SSDs to the cost-effective storage capacity of traditional HDDs. The purpose of the SSD in a hybrid drive is to act as a cache for the data stored on the HDD, improving the overall performance by keeping copies of the most frequently used data on the faster SSD. A SSHD resembles a standard HDD hard drive, but it also includes up to 8 gigabytes of high-speed flash memory. An SSHD is a combination HDD and SSD, offering up to 4 terabytes of storage that can be accessed several times faster than with an HDD. SSDs are more expensive than spinning disk drives. However, they have many advantages over their rivals, such as SSDs use smaller form factors so they can fit into smaller spaces, they run cooler, and they are much faster than spinning disk drives. So essentially, an SSHD is a combo of an SSD and an HDD. Let's talk about optical drive. So an optical drive is a type of computer disk drive that reads and writes data from optical disks through laser beaming technology. Optical drives are fading from standard system configurations, but are still useful for creating and installing operating system recovery disk images, creating and installing self-booting diagnostic apps, installing apps sold on DVD media, transferring information to other users, and creating DVD or Blu-ray movie discs. Optical discs for desktops use a 5.25-inch form factor, and most have a pop-out tray for loading media. The common optical drive markings are as follows. So you have one that's called Light Scribe that can record labeling information on the label side of the media and requires special Light Scribe media and software. Then you have the DVD multi-recorder that can read DVD-ROM, which is pressed media. It can read and write DVD-R, DVD-RW, and DVD-RAM media, and can erase and rewrite DVD-RW and DVD-RAM media. Next, we have RW, DVD plus RDL. These acronyms are something else, aren't they? But it can read DVD-ROM and can read-write DVD-R, which is a single layer, and DVD plus RDL, which is dual layer, and DVD plus RW, which is read, write, and erase. And then we have compact disc rewritable. It can read CD-ROM media. It can read, write CDR media. It can read, write, and erase CDRW media. Ultra speed drive supports CDRW disks with speeds up to 16x to 24x. Other speed grades include high speed, which is 8 to 12x, originally was 1 to 4x, and Ultra Plus, which is 32x. You guys don't have to be a subject matter expert on this. You just have to be familiar with the terms. Remember, this is the CompTIA IT Fundamentals exam. This is just giving you an overview of all of these various technologies. So do not get too caught up in trying to memorize all of these acronyms and what they mean. Okay? Cool beans. All right, moving on. Laptops with optical drives typically use a slimline drive with a pop-out tray. A similar design is used for optical drives that connects via USB 2.0 or faster ports. Media for optical drives can be divided into 3 categories. So you have compact discs, also known as a CD. The media has a capacity of 700 megabytes. DVD and Blu-ray drives can also read and write CD media. Then we have the DVD, stands for digital video disc. Media has a capacity of 4.7 gigabytes as a single layer and 8.4 gigabytes as dual layer. Blu-ray drives can also read and write DVD media. And then you have standard Blu-ray disc, also known as BD, has a capacity of 25 gigabytes as single layer with enhanced versions holding more data. Now, pressed CDs, DVDs, and Blu-ray media are read-only. CDRs, DVDRs, DVD plus Rs, and BDR discs can be written to but not erased. CDRWs, DVD-RWs, DVD plus RWs, and BD-RE discs can be written to, erased, and rewritten. DL discs feature 2 recording layers. Good Lord. These acronyms are all over the place when it comes to optical discs, ladies and gentlemen. All right, let's talk about Windows Drive Letter Assignment. So a Windows Drive Letter Assignment, also known as a drive letter, is a single alphabetic character from the letters A through Z that is assigned to a physical computer drive or drive partition. Windows assign drive letters in the order that drives are connected to the system. The drive SSD or spinning drive where Windows is installed is the C drive. If the system has an optical drive installed, the drive is normally assigned the letter D. Additional drives use drive letters E or above. Windows can also assign network folders that are shared with a computer a drive letter. When you move a drive from one computer to another, it might be assigned a different drive letter based on the drive letters already assigned to that computer. So you guys should be familiar with this screenshot here. When you guys go to My Computer, to see what drives are available. This is how the drive letters are assigned. Let's talk about flash drive. So a flash drive, which is also known as a USB flash drive, a data stick, a pen drive, memory unit, keychain drive, thumb drive, or a jump drive, is a portable storage device. It is often the size of a human thumb and connects to a computer via a USB port. Flash drives are an easy way to store and transfer information between computers and range in sizes from 2 gigabytes to 1 terabyte. Flash drives can be divided into 2 categories: USB and card-based drives. USB flash drives can be plugged directly into a USB port. Card-based flash drives must be plugged into a flash card reader before they can be used. Both types of flash drives are automatically assigned drive letters by Windows and are automatically recognized by Mac and by modern Linux distros. USB flash drives up to 32 gigabytes capacity are normally formatted using the FAT32 file system, and USB drives of 64 gigabytes capacity and higher are formatted using the exFAT file system. These file systems are supported by recent versions of Windows, Mac, and Linux. Most laptops and some desktop computers have flash memory card readers. Laptop card readers generally accommodate only 1 or 2 types of cards, typically the SD, SDHC, and the SDXC, and occasionally the Sony Memory Stick Duo. Portable card readers and desktop internal card readers connect to a USB 2.0 or USB 3.0 port. A multi-slot card reader might assign a different drive letter to each slot, enabling the reader to read multiple cards at the same time, or it might assign only 1 drive letter to all slots. So this is a card reader here. For those of you who are into photography, you take your pictures, they put them on these little SD cards or compact flash cards, and you plug those bad boys into it, and guess what? You can now look at your pictures on the computer. SD family cards are commonly used in the digital SLR, DSLR, or mirrorless cameras with interchangeable lenses, as well as digital point and shoot cameras. Micro SD and SD cards are available in 3 types. You have the SD Secure Digital, has capacities up to 2 gigabytes. You have the SDHC Secure Digital High Capacity, capacities up to 32 gigabytes. You have the SDXC, the Secure Digital Extended Capacity, with capacities starting at 64 gigabytes. To enable a micro SD card to work in a device that uses standard SD family cards, a micro SD adapter is used. Let me see, make sure I got my slides right. Okay. SD family cards use 2 different speed measurements. C-class refers to write speed in megabytes per second, with C10, which is 10 megabytes per second, being the fastest. UHS stands for ultra high speed cards, are available in U1, which is 10 megabytes writes per second. And U3, which is 30 megabytes write speeds. For recording HD video, use at least a C10 or U1 rated card. So these are the cards that you will find in your average digital camera. And then the image on the bottom there, that is a micro SD card. All right, let's talk about local network storage types. So there are 2 types of devices that allow for a single storage location on a network, which can make sharing files between devices easier and make data backup and restoration simpler. You have the first one, which is called a network attached storage, and then you have a file server. All right, network attached storage, a NAS system, is a storage device connected to a network that allows storage and retrieval of data from a centralized location for authorized network users and clients. NAS is a self-contained storage device that contains one or more drives, a network interface, and is bundled with software to enable computers on the network to access the device. A NAS device is built for use in business, but it may have two or more drive bays, permanent, easy upgrading of drives, and might also provide automatic mirroring, known as copying of the contents of one drive to another, which is known as RAID 1, which you'll learn about in later courses. Let's talk about the file server. A file server is a computer attached to a network that provides a location for shared disk access, i.e. storage of computer files such as text, image, sound, and video. And it can be accessed by workstations that are able to reach the computer that shares the access through a computer network. Current operating systems for PCs enable one computer to share files and folders with others. However, for faster performance, business networks use file servers. Also, a file server contains one or more drives, is connected to a network, and is designed to transmit and receive files from multiple devices at the same time using one or more gigabit Ethernet or 10 gigabit Ethernet network adapters. Data centers often use multiple file servers. All right, and let's talk about cloud storage devices. So, cloud storage is a model of computer data storage in which the digital data is stored in logical pools. The physical storage spans multiple servers, sometimes in multiple locations, and the physical environment is typically owned and managed by a hosting company. These cloud storage providers are responsible for keeping the data available and accessible, and the physical environment protected and running. People and organizations buy or lease storage capacity from the providers to store user, organization, or application data. As mobile computing devices such as laptops and convertible computers, smartphones, and tablets have become more widespread, the need for storage that can be accessed anywhere has also grown. Cloud storage services enable both personal and business users to access their information and apps anywhere an internet connection is available. Services such as Google Drive, Microsoft OneDrive, Apple iCloud, Dropbox, Amazon Drive, and others offer subscriptions that provide access to specific amounts of cloud-based storage. So the screenshot here you're looking at is that of Google Drive. If you guys have a Gmail account, then by default, you automatically have a Google Drive account, which can provide you, I want to say it's up to, 10? Let me check real quick. How much? You get 15 gigabytes of free storage when you have a regular standard Google Drive account. Now, if you want more or unlimited, I think you have to apply or sign up for like a business account, if I'm not mistaken. All right, so that is our class. So let's go ahead and do some check on learning, shall we? So, non-volatile storage is best described by which of the following phrases? Would it be, it works as long as the device is turned on? It is available in the DIMM form factor. It is only available as internal storage. It can connect using USB or SATA ports. So non-volatile storage. Non-volatile. The correct answer would be it can connect using USB or SATA ports. Remember, non-volatile storage is long-term storage that doesn't need power, doesn't need the machine to be turned on. So just think of a standard hard drive computer, a hard drive, and a hard drive connects to a computer how? If you have an external hard drive, it can connect to the computer via the USB port, or if it's an internal hard drive, it will connect via a SATA port. Next question, you need to install additional RAM into a laptop computer. Which of the following types of storage is suitable? Would it be DIMM? Would it be SSD? Would it be flash? Or would it be SO-DIMM? You're installing additional RAM into a laptop computer. The correct answer would be SODIMM. So if you guys recall, SODIMM stands for small outline dual inline memory module. So a regular DIMM, a dual inline memory module, is what you would normally install into a standard desktop. A SODIMM is what you would install into a laptop because it is a smaller form factor. All right, next question. Which of the following storage types is an example of volatile storage? Is it RAM? Is it SSD? Is it flash? Or is it cloud? Volatile storage, the opposite of non-volatile. The correct answer would be RAM, random access memory. Remember, volatile storage requires the machine to be turned on in order to temporarily store data or other processes that are associated with whatever program that you're running. The moment the computer turns off, the data that's stored in that RAM disappears, which is why it's called volatile. And it will be RAM. All right, so that is our class. So in summary, we have discussed various storage types such as volatile versus non-volatile, local storage types, local network storage types, and cloud storage devices. For more information, please visit my website, Technology G, so you can get read up on the latest and greatest to help you pass your CompTIA IT Fundamentals Certification exam. And until next video, peace.